In this video, we'll take a look at the effects of changing dimensions on area. So here's our first example. Find the area of the rectangle below. All right, so if we're given that this angle is 60 and we've got a right angle here, that means this angle has to be 30 if we're looking at this triangle. All right, so what we've got here is a 30, 60, 90 special right triangle, and we know the ratios of the sides are x root 3, and 2x. Across from the 30 is the 4, so this guy is 4. That means across from the 60 is going to be 4 roots 3. If I want to find the area of this rectangle, I need to multiply length times width. So 4 root 3 times 4, and that gives me, well, 16 roots 3. Okay, so what would happen if we changed one or both dimensions in the rectangle above? We know that the original area is 16 root 3. And that's not going to change for any of these problems. If we change the width so that the width, so it's twice as wide. So that means instead of having a side length that is 4, we have a side length that is 8. So 2 times 4, or 8. And we change the length so that the length is twice as long. That's going to be 2 times root 3. I'm sorry, 2 times 4 roots 3. And so that's going to be 8 roots 3. Well, our new area, if we multiply length times width, that's going to give me, well, 64 roots 3. Okay, so in this last box, it says take the new area divided by the original area. So if my new area is 64 roots 3, and I divided by the original area 16 roots 3, well, the roots 3's cancel, and 64 divided by 16 is 4. So the area has increased 4 times. Okay, let's take a look at the next row. It says we're going to keep the width the same. So this is still going to be 4. But we're going to increase the length 3 times. So it's going to be 3 times 4 roots 3. When you're multiplying, you multiply numbers that are outside. So it's 4 times 3, and that gives us 12 roots 3. So my new area, length times width, would be 12 roots 3 times 4, or 48 roots 3. Okay, so let's take the new area, 48 root 3, and the old area. Again, my roots 3 cancel, and the 48 divided by 16, that gives us 3. Okay, let's take a look at a couple more. 4 times as wide. So if my width is 4, and I want it 4 times, that's going to give me 16. But this time we want it half as long. So this time half of 4 roots 3. Half of 4 roots 3 is 2 roots 3. To find the new area, length times width, we've got 16 times 2 roots 3 is 32 roots 3. So the new area divided by the old area, this is going to give me 2. And last problem. 1/4 is wide. So if my width is 4, 1/4 times 4 is going to give me 1. Twice as long. So 2 times 4 roots 3, that's going to give me 8 roots 3. My new area, length times width, is going to give me 8 roots 3. 8 roots 3 divided by 16 roots 3. Let's cancel the roots 3, and 8 over 16 is 1/2. So what can we conclude regarding the changing of dimensions in a two-dimensional figure? Well, here it is. The change in dimensions multiplied together is the scale factor. It is multiplied to the original area to get the new area. So the new area is equal to the scale factor times the original area. Okay, so let's just make sure we understand. My original area was 16 roots 3. And the change in dimensions multiplied together. So twice and twice, that's 2 times 2 is 4. That's my scale factor. So if I want to find the new area, I would take 4 times 16 root 3 to get my new area. Okay, so this stays the same. This is 3 times as long. So the change in dimensions is just 3 times. That's my new scale factor. 3 times 16 root 3 is 48 roots 3. 4 times as wide, half as long. So 4 times a half is 2. 2 times 16 root 3 is 32 roots 3. And in the last one, 1/4 times 2, 1/4 of 2 is a half. A half times this, 16 roots 3, is 8 root 3. Let's take a look at another example. Find the area of the triangle below if its base were doubled and the height was tripled. So that's what we're going to do. We're going to double the base and triple the height. So first let's find the original area. So area of a triangle is 1/2 base times height. And so in this case, I've got 1/2 times 12 times 7, which is 42 centimeters squared. Okay, so if I were to double, that means times 2, and triple times 3. The product, 2 times 3 is 6. That's my scale factor. So the area of my new triangle would be 42 times 6. And let me take that to a calculator real quick. And that's 252. Okay, so I'm going to go ahead and work it algebraically just to make sure. So the base were doubled. So this guy is going to be 24. The height were tripled. 3 times 7 is 21. So 1/2 base times height. Take that to a calculator. We get 252. That's a centimeter, sorry, a little bit messy. Example 3, find the area of the rhombus below if one diagonal was halved. Okay, so we're going to cut this guy in half, and the other diagonal were doubled. Okay, so let's just think about this. This is going to be 1/2, and this is times 1/2, and this is times 2. The scale factor is, well, 1/2 times 2, which is 1. So our area should not change. All right, so area of a rhombus is 1/2 the product of the diagonals. Diagonal 1 times diagonal 2. So 1/2, and let's see. We know that this piece is 5, and so this piece is also 5. So we'll call diagonal 1 10 units. And diagonal 2, well, I've got this piece is 4, and so this piece is 4. So that's going to give me 8. Half times 10 times 8, so let's see. Half times 10 is 5, times 8 is 40. So the area of my rhombus is 40. Okay, so if the scale factor is 1, this is also going to just be 40. And these are in inches squared. That little, 2 little, whatever those marks are, that just represents inches. Okay, so now let's go ahead and work it algebraically just to prove this. If I were to half one of the diagonals, so let's say we'll call this one 5 and double the other diagonal 16, that's also going to give me 40. So there was no change there. In example 4, the area of the triangle is 36 square millimeters. Suppose the height was 3 times as long and the base was 4 times as long. Okay, so that means we're going to times 3 and times 4. I know my scale factor is going to be 12. 4 times 3, which is 12. What would the area of the new triangle be? Well, if we're given that the area of the triangle is 36, the new triangle would be, well, 36 times the scale factor. So 36 times 12, and that gives me 432. And let's see, this is millimeters squared. One more example. Example 5, if the area of a square is 256, so we're given the area of the square. What would be its area if the width twice as long and the length was 1/8? So this is times 2 and this is times 1/8. So my scale factor, 2 times 1/8, well, if I put that 2 over 1, that's going to give me 2 over 8 when you multiply straight across, and then I can reduce that. My scale factor is 1/4. So to find the new area, I'm going to take the old area, 256, and multiply it by the scale factor. If I take that to a calculator, that gives me 64. My new area is 64 meters squared.